First, get a rock. Then, smash the rock. Now, you've got 98% concentrated silicon dioxide. Now purify it to 99.9% pure silicon dioxide. Purify it to 99.999999% polysilicon metal. Put the polysilicon ingots into a crucible. Heat the silicon ingots to 1698 degrees Kelvin. Take a small seed monocrystal and dip it into the vat of molten silicon. Slowly pull the crystal out as it cools. Now, you've got a monocrystal of pure silicon. Next, cut the monocrystalline silicon ingot into thin slices. Now you've got pristine, freshly cut silicon wafers. Dope it with some boron or phosphorus. Put photoresist on the wafer. Take your chromium-etched photolithographic quartz mask and shine a laser beam through it onto the wafer. The shadows produced by the photomask will control the location of highly localized chemical reactions on the surface of the silicon wafer. Now develop the photoresist. Acid etch the exposed parts of the wafer. Wash away the leftover photoresist. Now do some homoepitaxy, heteroepitaxy, pseudoepitaxy, diffusion doping, copper interconnects, chemical mechanical polishing. Now you've got a finished silicon wafer. Cut your silicon wafer into pieces. Now you've got unpackaged silicon dies.